I'm Anil Kumar. Welcome to my series on graph. In this playlist, we'll have a lot of graphs for you, and I hope at the end of the playlist you will understand all the concepts required to answer questions related to the topics mentioned here. We'll discuss basics of graphing on coordinate planes, difference between plot graph and sketch graph, these two terms are commonly used, approximate slope of tangent at a point, area enclosed between lines, distance speed time graph. We'll solve equations using graph and also solve inequalities in this particular playlist. To give you an idea, whenever we talk about graphs, we are most of the time plotting them on a coordinate plane, right? So here is a coordinate plane. It will have origin O, horizontal x-axis and the vertical y-axis. Now these axes can be labeled, and you could have x, y, z, anything on the horizontal x-axis. The only thing important here is that this is a two-dimensional representation, so it is basically a 2D representation. So you need x and y two values. So normally whenever we say x value, we are looking for independent variables. So normally we'll put independent variable here. On the y-axis, we'll put the dependent variable. Set of points will define our graph. Connecting them with a smooth curve is what is meant by plotting graph. So basics about graphing is to understand what are going to be your points and how are they going to be connected to get the graph in a way, right? Then difference between plotting graph and sketching graph. Let's take an example. Let us say that I have to plot graph of y equals to 2x minus 1. Okay. Now, if I am sketching, let's go for sketching first. If I am sketching graph, I could make a rough sketch. So sketching is rough. So what we will do here is that on our coordinate plane, we'll say minus 1 is the y-intercept. So we say this is minus 1. And the slope is 2. So that means rise over run. So we go 1, 2, and 1 this side, we get a point. 1, 2, 1 this side, we get another point. Connecting these points, what we get here is the sketch. So sketch basically is rough. Now, if I have to draw or plot a graph, in that case, we need points. So we need these coordinate points. So for each value of x, at least 5 of them will calculate the y values, right? For example, if I place x as minus 2, calculate the value, minus 2 times 2 is minus 4, and that gives me minus 5. For minus 1, the y value will be minus 3. For 0, the value will be minus 1, the y-intercept. For 1, the value will be 2 minus 1, which is 1. And for 2, it will be 4 minus 1, which is 3. So we have a set of points and we know the nature of the graph. It is a straight line. So we'll actually plot these points, right? And once we have these points, we'll connect them with a straight line. So showing these points and then connecting is plotting the graph. So plotting is more accurate. So whenever you have to solve equations, right, and to work more in details with the graph, you will be plotting the graphs with the help of coordinate points. Perfect. Now let's talk about approximate slope of a tangent line. Now, many graphs can be solved, or we could know something better about them using rate of change. For example, if I have a graph which is kind of like this, right? In that case, if I know some point here, then to find the rate of change at that particular point, we need to sketch the tangent line, right? So something like this. Now this tangent line slope can be calculated by finding change in y over change in x, right? So that is, let us say, rate of change is equals to delta y over delta x. So we could actually find rate of change. This really helps, especially if you're working in graphs for velocity and time, right? So in that case, rate of change in velocity and time graph will be acceleration, right? So acceleration will be change in velocity with change in time, right? For example. So we could find another parameter from the graph using rate of change. And that could be done fairly accurately, but well, it will always be an approximate value, and therefore this word is being qualified by approximate slope of a tangent at any point, right? So we'll see the application in distance speed time graph. Then we'll talk about area enclosed between lines. Now we'll actually restrict ourselves to most of the time linear graphs when we are working to find area enclosed. So if we have a couple of linear graphs, for example, if this is one graph, and let's say that is another graph, and we have another graph which is, let me just sketch with a different ink. For example, we have a graph like this, right? So you see these three graphs enclose a particular triangle. We could always find the area enclosed within this particular triangle. And this area can help us find very significant values, correct? Now, we could also solve inequalities, right? Let's say this is line number 1, this is line number 2, and this one is line number 3, right? So let's say this is line number 3. So we can see that this area enclosed is the area for the values for line less than the line number 1, right? So less than, and this is greater than this line, and it is on the right side of that, correct? So what different kind of questions can involve some parameters where this could be of use. So we are going to see how to find area and then how to solve equations and inequalities with the help of graph. Here is an example just to illustrate. So I'll attach a set of videos to this particular discussion which will help you to understand exactly how to calculate and work for all these values. We'll have additional examples in our playlist. Feel free to watch those videos to understand this topic better. Thanks for your time and all the best. We've discussed different types of questions, and in this video we'll talk about graphing solution of equation. The question here is, find the shortest distance between the point 6 minus 1 and the line y equals to 2x minus 3. We're going to use the graph to figure out the shortest distance. So the first step involved will be to graph the line, right? So first we'll plot the line. Y equals to 2x minus 3. Now to plot this line, we need some points. At least 5 points should be taken, correct? So let me make a table of values here. For different values of x, we'll calculate the values of y. Good value, of course, is 0. We know that y-intercept is minus 3 here. So at 0, we have minus 3. If I put x as 1, I get 2 minus 3, which is minus 1. For 2, I get 2 times 2 is 4. 4 minus 3 is plus 1, correct? And for 3, 6 minus 3 is plus 3. We can take some negative values now. Minus 1 will give it minus 2 minus 3, which is minus 5, right? So with these values, we'll sketch our line. So we have taken most of the points on the right side. So let me just put it like this. The y-intercept minus 3, the y values most of the time, they are more negative. Okay, so we'll go like this. The values help us to choose scale as well as the axis on the given graph. So here you have the x-axis, the y-axis, and 0. Let's plot these points. Minus 1, minus 5. So at minus 1, we have 1, 2, 3, 4, 5. At 0, it is minus 3. The slope is 2, so we are going up by 2, right? So that is kind of a check. And then again, minus 1, then again, it should be 1 and then 3. Correct? It makes sense since the slope is 2. So we get our line, which should be connected. So all these points will fall on a line which is given by the given equation, right? Okay. Now we are given a point which is 6 minus 1. So 1, 2, 3, 4, 5, 6 and minus 1. So that's the point given to us. We now want to find the shortest distance between these two. How are you going to do it? Well, shortest distance will give a perpendicular path, right? So we need to look for the perpendicular path for shortest distance. Clear? Now slope of the line is 2. So here the slope has to be minus half. Is that clear? So the slope has to be minus half since the slope of the line is 2. Now minus half, so let's get into the slope of minus half from here. Minus half means we could go up by 1 and 2 left, right? So that will give us minus half. So it is minus 1 over 2 means you go down and 2 right, so you move this side. That is also negative, but we could do 1 up and 2 left. So 1 up and 2 left, 1 up and 2 left, 1 up and 2 left. So you have seen from here that a line which is perpendicular to the given line from the point given to us, which is 6 minus 1, intersects on a line, and from the graph we can read this point of intersection. Does make sense to you, right? Since this is the point of intersection, we know this point is closest to the given point. The point here is 2, 1. Since we know these 2 points, we can find the shortest distance, correct? So we can now write the distance is square root of difference in x values, which is 6 minus 2 whole square plus minus 1 minus 1 whole square root, correct? That is square root of 4 square, which is 16, plus 2 square, which is 4. So that gives you square root of 20, or 4 comes outside as 2, square root 5. Do you see that? So that becomes the exact value of the distance between the point and the line. So using a graph, we can fairly find the distance between the point and the line as shown here, correct? So that is how we can do it. I hope the steps are absolutely clear. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Perfect. The question here is, assume the graph of y equals to x squared minus 5x plus 3 is given to you. Explain how you can find solution to the following. So if you are given this graph, you need to find how to find solution of the equation x equals to 4 minus 1 over x squared and 2x squared equals to 10x plus 2. You can pause the video, answer the question, and then look into my suggestions. Let us rearrange the terms given to us. We have x equals to 4 minus 1 over x. Definitely x is not equal to 0. So if you get x equals to 0 as a solution, that will not be counted as a solution. Now let's multiply by x all the terms. We get x squared equals to 4x minus 1. Bringing them together, we get x squared minus 4x plus 1 equals to 0. However, what is given to us is x squared minus 5x plus 3. And we have x squared minus 4x plus 1. How do we make this same? That is what the criteria is, right? Now to make it same, I should be adding minus x to make it minus 5x and here plus 2. So we have to add this to both the sides, correct? So we'll add it to both the sides. So we'll add this to left side as well as to the right side, correct? So if you do that, what you get here is x squared minus 5x plus 3 equals to minus x plus 2. You get the idea, right? So that clearly means that on this graph of y equals to x squared minus 5x plus 3, if I plot a straight line minus x plus 2, then the intersection will provide me with the solution, correct? So what we're trying to say here is that if we are given this graph, let's say, well, let's make a rough sketch, okay? Let's make a rough sketch here. Let us say that we are given this graph. It opens up with y-intercept at 3. So that is the graph given to us, right? Y equals to. Now on this particular graph, if I plot this line minus x plus 2, so 2 will be somewhere there, right? This point is 3 for us. Minus x means the slope is negative. So something like this. Then these points of intersection will be the solution. Is that clear to you, right? So in this case, we have intersection with line y equals to minus x plus 2. Right? That provides you the solution. Is that clear to you? Now let's do for the second equation. We are given here 2x squared equals to 10x plus 2. Let's bring all the terms together. Rather divide by 2 first. So we get x squared equals to 5x plus 1, right? So we can divide by 2 both sides. Now bring all the terms together. X squared minus 5x minus 1 equals to 0. But what we need is plus 3. We already have x squared minus 5x. To get plus 3, I should be adding 4 on both sides, right? So we get x squared minus 5x plus 3 equals to 4. So we added 4 on both the sides. So when you add 4 here, you need to add 4 on the other side. Minus 1 plus 4 is plus 3. And what you get here is the graph given to you. The other side is the number 4. So in this particular case, the line y equals to 4 will provide solution. Is that clear? So what I'm trying to say here is that in this particular case, if I draw a horizontal line y equals to 4, let's say like this, then we will have intersection at 2 points, and those 2 points will be the solution of the given equation. Is that clear to you? So in this video, we will learn how to find some graphing solutions from the given equation. The question here is, draw the graph of y equals to minus x squared plus 2x plus 4, use the graph to find approximate value for minimum, right? So, and B is gradient of the tangent at x equals to minus 1, correct? So that's the question for you. You can always pause the video, answer the question, and then look into my suggestions. Now let us see how to draw the graph. So when it is draw the graph, you have to find few points, at least 5, right? So to find the points, coordinates of the points, what we'll do here is that we'll calculate the values for different values of x. The equation is y equals to minus x squared plus 2x plus 4. So we'll take some values of x and then calculate what is minus x squared, what is 2x, we'll add 4 to it, and once we do all that, we'll get the y values, right? So that is how we are going to build it up, right? It's a good practice to start with 0. So let's start with 0. So if I put 0 for x, in that case, we get 0 here, and 4. That is the y-intercept. For 1, it'll be minus 1. This will be 2. That will be always 4. Now we get 6 minus 1 as 5. For 2, we get minus 4. That is plus 4 and 4. And this cancels and we're left with 4. So this graph basically, as the equation suggests, we are looking for a parabola which is kind of like this, right? So what we have already noticed is that we got a maximum value of 5 and kind of symmetrical values there. 3. 3 is 9, so minus 9. 3 times 2 is 6, and this will be 4. So 10 minus 9 is 1. For 4, we get minus 16. 4 times 2 is 8, and that is 4. 12, we get minus 4 here, right? Let's take some values on this side now, minus 1. So that will give us minus 1 here, minus 2, and then 4. And that gives you a value of 1. So you can now see the symmetry, 5 being the maximum, and you get 4, 1, 4, 1 on either side. So actually we are good to now sketch this particular parabola. We clearly know that the maximum value is 5, and the x values which we have chosen is from minus 1 to 4. So we'll focus more on the right side. We need to keep 1, 2, 3, 4, 5 here. Okay, so let's do like this. Right. So let's keep it like this as the horizontal x-axis. Since we have taken more positive values, we'll just draw the y-axis slightly on the left. To sketch the points, we may begin with the maximum itself. So we clearly see that this gives you maximum. At 1, we have 5, right? And then that becomes the axis, and we can plot the other points. So at 1, we have 5. 1, 2, 3, 4, 5. Then at 2 and 0, we have 4. So from the symmetry, we can get those points. Then we have 1. So we have 1 here. And then we have minus 4. So 1, 2, 3, 4. We can also place this point at minus 4. So that gives you the graph. We can actually sketch this parabola. So moving upwards, kind of like this. Smooth curve, right? You see this. And then we'll go down in this fashion, right? So we have this graph. Okay. So it has to touch it anyway, not bad. So we have a parabola which represents the given equation, which for us is y equals to minus x squared plus 2x plus 4. Perfect. So we have done the first part. Now, second part is use the graph to find the approximate value of the maximum. So clearly the maximum is the turning point, right? So So we have the maximum value, which is 1, 2, 3, 4, 5, right? So this is 5 for us. Now this is y-axis. That is the x-axis, correct? This is 0. So we have maximum value as 5. Gradient of the tangent at x equals to -1. So at this point, we have to draw a tangent line and then find its gradient, right? So let's sketch one. We'll find rise over run with the help of this particular tangent. So what we will do here is, let's draw a tangent here. So, okay. So what we can do is, okay, so, it could be something like this. So you just place this line, so that's just tangent at this particular point, and this is going to be an approximate value. So let's draw the tangent. So we have drawn the tangent at x equals to -1. Now we need to find the slope of this particular tangent. So the slope we can now calculate with rise and run. So one of the good points which this tangent has passed through is definitely here. And then we have this point itself. So we can find the slope as rise over run, correct? So at this stage, the change in y value is 1, 2, 3, 4. And change in x value is 1 unit, right? And of course, the slope is positive. So we get the gradient as ratio of change in y over change in x. In this case, it is 4 over 1. So the gradient is 4, right? So the graph can help us to estimate the slope at any particular point, right? So that gives you the slope of the tangent at any particular. In this video, we'll try to understand speed time graph, and from the given graph, we'll sketch acceleration time and distance time graphs. The question here is, for the following speed time graph, sketch a possible acceleration time graph, sketch a possible distance time graph. Let's first try to understand the given graph. It is velocity, which is same as speed, and time. Say velocity, we are also worried about the direction. Now we are given here that object starts from the starting point, which is here at the origin. So velocity is 0 at t equals to 0. It reaches a maximum velocity of 30 meters per second after a period of, total duration of this is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are unit seconds, right? So that will be 3 seconds, and this will be 2 less than 10, 8 seconds, correct? So we can actually describe this that the object starts and it accelerates at a constant rate, increasing the velocity from 0 to 30 meters per second in 3 seconds, right? And then travels at a constant velocity, 0 acceleration, for 5 more seconds, and then return back to the starting point very fast within 2 seconds, right? So the velocity drops from 30 meters per second to 0 within a period of 2 seconds. That is deceleration. Perfect. Now with that information, let us now talk about sketching the acceleration. So acceleration is rate of change of velocity, right? So it is rate of change of velocity. Now both acceleration and velocity have direction. So a negative value will indicate the opposite direction. So in this particular case, there are 3 legs in which the acceleration is changing. So we'll define them with our points A, B, and C. So in the very first stage, where the acceleration is constantly increasing, right? Velocity is constantly increasing. There's a constant acceleration. Let's find acceleration in the duration 0 to A. When we say rate of change, that means the value at the end minus value in the beginning. We have 30 meters per second minus 0 meters per second divided by time, which is 3 seconds minus 0 seconds, correct? So that gives you 30 meters per second over 3 seconds. And so we get 10 meters per second square, right? So meters per second square is the unit for acceleration. In the second interval, which is from A to B, the change in velocity is 0 since it remains 30 meters per second. Is that clear to you? And the time changes from 3 seconds to 8 seconds. We'll do 8 minus 3 seconds. We get 0 over 5 meters per second square, and that is 0. In the third interval, which is from B to C, we observe that the velocity changes from 30 meters per second to 0, so we'll get 0 meters per second minus 30 meters per second divided by 10 minus 8 seconds, correct? So we get minus 30 meters per second divided by 2 seconds. That gives us minus 15 meters per second square. So these are the values in the given intervals which we need to now plot to get sketch of acceleration time graph. So let's write acceleration time graph. So we have to say 10 meters, 0 and minus 15. So let's make a scale for this. We are going up to minus 15. So looking at this, we'll write this as 5 units, right? So 5 units, this will be minus 5, right? So we are now writing acceleration A in meters per second square along the vertical. Time we are keeping same. So in the first interval, acceleration is 10 meters per second. So let me use a different color to sketch it. 10 meters per second is constant in this interval for the first 3 seconds. So that is our 10 meters per second, correct? Then we have 0 meters per second. So that is 0 meters per second, clear? And then we have minus 15. So 5, 10, 15 in the last phase. So these horizontal lines represent the acceleration for the given situation. Is that clear, right? So we have this as minus 15, right? This is minus 10, and that is 10 meters per second square for us, right? Now let's talk about distance time graph on a fresh page. So now let's sketch a possible distance time graph for the given velocity time graph. The object moves initially with 0 velocity, increasing it to 30 meters per second within a period of 3 seconds, right? And then 1, 2, 3, 4, 5 seconds, that means 8, it moves with a constant velocity. So even when the object is moving at a constant velocity, distance is increasing, remember that. Now here, the object comes back to the starting point. The displacement is 0. However, the distance further increases. It traveled more distance, correct? So now, keeping that in mind, let us try to sketch the distance time graph. One more thing to remember is, when the velocity is increasing, then the rate of change of distance is also increasing. So we have a non-linear graph, right? So in the portion where we show kind of like this, the distance graph will be increasing at a non-linear rate. So in this portion, in the first portion, the distance time graph will be rapidly, distance will be increasing, right? Now at this stage, the velocity is constant. So the distance increases at a constant rate and it will be a straight line. So whenever you're talking about non-linear curves, it could be in this fashion or in the other way, depending on whether it is slowing down or speeding up, right? So negative speeding is also speeding, correct? So that distance will also be like shown as a curve, right? Now, let us see how we are going to display this on the graph. So first, let me divide this particular portion into groups as we did last time. Let it be O to A to B, and B to C. Distance is basically area under the graph. So let's find the distance traveled from O to A. So we'll calculate the area under this graph. So that is to say, we'll find the area of this portion, right? So area of portion, that will give us the distance, maximum distance covered at this point, that is in first 3 seconds, right? So in first 3 seconds, area A1 in this graph is A1, area of the triangle, which is half of base is 3 seconds, right? So we'll write 3 seconds times height, which is 30 meters per second. 30 meters per second, right? So 3 goes 15 times, and this is 45. You can always use calculator, right? So we get 45 meters as our unit for this. You can clearly see that the unit seconds and seconds cancel, so we're left with meters. Perfect. In this portion, the distance traveled is how much? It is a rectangle. We're talking about this area now from A to B. So it is 5 units in seconds, right, times velocity is 30 meters per second. So we get 5 times 30, which is equals to 150 meters. Now the third area A3, let's calculate this distance also, is equal to, it's a triangle, half, base is 2 seconds, right, 2 seconds, times height, which is again 30 meters per second. So 2 and 2 cancel and we get 30 meters. So we get 45 meters in the first leg, 150 meters in the second, and 30 meters in the third leg, right? So the distance is always increasing. Let's plot these points. So we are looking into the points which are for us at 3 seconds, distance is 45 meters. Now at 8 seconds, distance will be combination of these two, right? So it's 150 more, that makes it 195. And then at 10 seconds, the object moves further away by 30 more meters. So it will be 5, 3, 12 to 225 meters, right? So we're talking about now time and distance, correct? So we have to plot these points. So we have to plot 45, 195, 225, correct? So let us draw it here. So we'll take this as our distance and time. So time will be shown on the horizontal as we did earlier. We'll keep the same time as we did earlier in seconds, same scale I mean. But for distance, we have to define a new scale, right? So let's say if you go by 50, 100, 200, 250, that should be fine, right? So we will go with 50s, rather 25s. So I'll write here 50, 100, 150, and 200. So these are distances. So we'll say distance in meters, right? So that is the vertical axis. Now time in seconds. So that is same as we have 3 here. So let's this be, okay, so 3, 1, 2, okay. So that is 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I've marked those which are of prime importance. Now at 3, we have 45. So at 3, the point 45 will be close to, this is 25, right? So at 3, it will be somewhere here. Then at 8, we have 195, close to 200. So at 8, it is close to 200. Let's say this is our point, but less. And this is 225 at 10, so it reaches there, correct? So these are the 3 points, starting with 0, of course. Now, as I was saying, shape of the graph is very important. So let's look into the shape. Since the distance is increasing all the way through, we'll go and at a constant rate. So that is rate of change is increasing. So if I draw a tangent here and there, is steeper as we move forward. So that indicates higher velocity. Now from here to here, it is a constant rate, so that should be connected with a straight line. So this is a straight line for me, correct? Now again, the distance is increasing, right? In fact, it is even faster, right? So it is increasing, so we'll again do like this. It decreases, velocity decreases from higher value to lower, so it actually goes kind of like this, not this. Okay. So in the later half, the velocity decreases from 30 to 0, distance increases, but at a lower rate, right? So this portion will be kind of like this. So the distance is increasing, but at a lower rate, right? So it drops from this slope, which was 30, to 0. So it will be kind of like this, tapering down, as you can see, a horizontal line here at the tip, right? So it becomes almost 0. So it will be almost 0 when we start with, you see, just kind of like this, and end also with 0. That means if I draw a tangent here, it will be horizontal. So that's kind of important to understand. And the points mentioned are the given here, right? So this point for us is 345. The other point is 195. And the third point is 225. On this distance time graph. Perfect. So that is how we'll get our graph. So I hope the concept is absolutely clear. It is kind of important to show the gradient here in the form of a curved surface so that we can represent the increase from 0 to 30 for velocity. A straight line indicates a constant velocity of 30 meters per second. And this curve, which is parabola opening downwards, indicates that the velocity decreases at a rate which is constant. Right? We worked in acceleration as 15 meters per second, right? From 30 to 0 meters per second. Perfect. So that is how we should be drawing these graphs from velocity time graph. I hope the concept is absolutely clear. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.